terms line and load in relation to circuit breakers refer to the terminals used for connecting the power source and the protected circuit. The line terminals, sometimes designated as L, on the circuit breaker receive power from the main electrical panel or power source. The load terminals, sometimes designated as N or A, on the circuit breaker connect to the circuit or load being protected. Underwriters' laboratories and other certification organizations evaluate and list circuit breakers based on whether they are designed for line-side or load-side mounting. Circuit breakers that are approved for use as line or load breakers will be clearly marked on their labels or documentation. It is crucial to use circuit breakers properly and connect them according to the line and load designations. Using a circuit breaker with an incorrect line or load connection can firstly compromise electrical safety, secondly void warranty and underwriters' laboratories listing, and thirdly cause damage to the circuit breaker or other electrical components. For most residential and commercial applications, circuit breakers are designed to be mounted on the line side with the power source connected to the line terminals. Single-pole circuit breakers typically have a clear voltage rating such as 120 volts or 240 volts and can be used on either the line or load side. Multi-pole circuit breakers, such as 2-pole or 3-pole, are typically designed for line-side mounting only. Always consult the manufacturer's specifications and local electrical codes for specific installation requirements. Correctly identifying and connecting the line and load terminals of a circuit breaker is fundamental to ensuring the safety and proper operation of electrical systems. A circuit breaker is a crucial safety device designed to protect electrical circuits from overcurrent conditions, which can lead to overheating, damage, or even fire. Its primary function is to interrupt the flow of electricity when the current exceeds a predetermined level. The line side of a circuit breaker refers to the terminals that are connected to the incoming power source, typically the main electrical panel or distribution board. This is where the electricity enters the circuit breaker before being distributed to the load. The load side, on the other hand, refers to the terminals that are connected to the circuit or equipment being protected by the circuit breaker. This is where the electricity exits the circuit breaker and flows to the devices or appliances that it is intended to power. Incorrectly connecting the line and load wires can have serious consequences. Firstly, it can compromise the safety of the electrical system and increase the risk of electrical shock or fire. Secondly, it can damage the circuit breaker itself, rendering it ineffective and potentially creating a hazardous situation. Thirdly, it can void the manufacturer's warranty and any certifications, such as Underwriters Laboratories listing, that the circuit breaker may have. Underwriters Laboratories is a globally recognized safety certification organization that tests and evaluates products to ensure they meet established safety standards. Circuit breakers that are Underwriters Laboratories listed have been subjected to rigorous testing to verify their performance and reliability. The Underwriters Laboratories listing mark indicates that the circuit breaker has been found to comply with the applicable safety requirements and is suitable for its intended use. When installing or replacing a circuit breaker, it is essential to carefully identify the line and load terminals and connect the wires accordingly. The terminals are typically marked with the letters L for line and N or for load. However, it is always a good practice to consult the manufacturer's instructions or the circuit breaker's label to confirm the correct wiring configuration. In most residential and commercial applications, circuit breakers are designed to be mounted on the line side with the power source connected to the line terminals. This configuration ensures that the circuit breaker is able to effectively protect the downstream circuit from overcurrent conditions. Single-pole circuit breakers, which are commonly used for 120-volt circuits, typically have a clear voltage rating and can be used on either the line or load side. However, it is important to verify the specific instructions for the particular circuit breaker being used. Multi-pole circuit breakers, such as 2-pole or 3-pole circuit breakers, are typically designed for line-side mounting only. These circuit breakers are used to protect circuits with higher voltage ratings, such as 240 volts or 480 volts, and are often used for appliances like electric stoves, water heaters, and air conditioners. In addition to correctly connecting the line and load wires, It is also important to ensure that the circuit breaker is properly sized for the circuit it is protecting. The circuit breaker's amperage rating should match the ampacity of the circuit wires and the load being served. Using a circuit breaker with an amperage rating that is too high can allow excessive current to flow through the circuit, potentially causing overheating, damage, or fire. Conversely, using a circuit breaker with an amperage rating that is too low can cause nuisance tripping, which can be disruptive and inconvenient. When selecting a circuit breaker, it is also important to consider the type of circuit being protected. Different types of circuit breakers are designed to protect against different types of overcurrent conditions, such as short circuits, overloads, and ground faults. For example, ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults, which can occur when electricity flows through an unintended path to ground. GFCIs are commonly used in bathrooms, kitchens, and other areas where water is present. Arc fault circuit interrupters, or RFCIs, are designed to protect against arc faults, which can occur when electricity jumps between two conductors, creating a spark. RFCIs are commonly used in bedrooms and other areas where flammable materials are present. Regular inspection and maintenance of circuit breakers are also essential to ensure their continued reliability and effectiveness. Circuit breakers should be visually inspected periodically for any signs of damage, such as cracks, discoloration, or corrosion. They should also be tested regularly to verify that they are tripping properly. This can be done using a circuit breaker tester, which is a device that simulates an overcurrent condition and verifies that the circuit breaker trips as expected. If a circuit breaker is found to be damaged or not functioning properly, it should be replaced immediately by a qualified electrician. Attempting to repair a circuit breaker yourself can be dangerous and is not recommended. In summary, understanding the line and load connections of circuit breaker is crucial for ensuring the safety and proper operation of electrical systems. By correctly identifying and connecting the line and load terminals, selecting the appropriate type and size of circuit breaker, and performing regular inspection and maintenance, you can help protect your home or business from electrical hazards. Always consult with a qualified electrician if you have any questions or concerns about circuit breakers or any other electrical work. Remember that electrical work can be dangerous and should only be performed by qualified individuals who are familiar with the applicable safety codes and regulations. Firstly, identify the line and load terminals on the circuit breaker. The line terminals are typically marked with the letter L, while the load terminals are marked with the letter N or A. Secondly, connect the incoming power source to the line terminals. This is typically the main electrical panel or distribution board. Thirdly, connect the circuit or equipment being protected to the load terminals. This is the wiring that will carry electricity to the devices or appliances being powered. Fourthly, ensure that the circuit breaker is properly sized for the circuit it is protecting. The circuit breaker's amperage rating should match the ampacity of the circuit wires and the load being served. Fifthly, test the circuit breaker to verify that it is tripping properly. This can be done using a circuit breaker tester. Sixthly, visually inspect the circuit breaker for any signs of damage, such as cracks, discoloration, or corrosion. Seventhly, consult with a qualified electrician if you have any questions or concerns about circuit breakers or any other electrical work. Incorrect wiring of line and load connections can lead to several dangerous consequences. 1. Electrical shock. If the line and load wires are reversed, the circuit breaker may not be able to effectively interrupt the flow of electricity in the event of an overcurrent condition. This can increase the risk of electrical shock to anyone who comes into contact with the circuit or equipment being protected. 2. Fire hazard. Incorrect wiring can also cause the circuit breaker to overheat, which can lead to a fire. If the circuit breaker is not able to trip properly, the excessive current can cause the wires to melt and ignite nearby materials. 3. Equipment damage. Incorrect wiring can also damage the equipment being protected by the circuit breaker. If the voltage is not properly regulated, it can damage sensitive electronic components. 4. Voided warranty. If the circuit breaker is not installed according to the manufacturer's instructions, it can void the warranty. This means that you will not be able to get the circuit breaker repaired or replaced if it fails. 5. Code violations. Incorrect wiring can also violate local electrical codes. This can result in fines or other penalties. To avoid these consequences, it is important to always follow the manufacturer's instructions when installing or replacing a circuit breaker. If you are not comfortable doing electrical work yourself, it is best to hire a qualified electrician. The National Electrical Code, or NEC, provides comprehensive guidelines for the safe installation of electrical systems. It is important to adhere to these guidelines to ensure the safety of people and property. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. Some specific NEC articles that are relevant to circuit breaker line and load connections include: firstly, NEC Article 240.1, which covers overcurrent protection in general. Secondly, NEC Article 240.21, which covers the location of overcurrent protection devices. Thirdly, NEC Article 240.85, which covers the identification of circuit breakers. Fourthly, NEC Article 408, which covers switchboards and panel boards. Always refer to the latest edition of the NEC for the most up-to-date requirement. Always disconnect power to the circuit before working on any electrical components. Use insulated tools to prevent electrical shock. Wear appropriate personal protective equipment, such as safety glasses and gloves. Never work on electrical systems in wet or damp conditions. If you are not comfortable doing electrical work yourself, hire a qualified electrician. When dealing with electrical systems, safety should always be the top priority. Never take shortcuts or compromise on safety to save time or money. In addition to the line and load connections, there are other important factors to consider when installing or replacing a circuit breaker. Firstly, the interrupting rating. The interrupting rating of a circuit breaker is the maximum amount of current that it can safely interrupt. The interrupting rating should be high enough to handle the potential fault current at the point of installation. Secondly, the voltage rating. The voltage rating of a circuit breaker is the maximum voltage that it can safely handle. The voltage rating should match the voltage of the circuit being protected. Thirdly, the ambient temperature. The ambient temperature is the temperature of the air surrounding the circuit breaker. The circuit breaker's amperage rating may need to be adjusted based on the ambient temperature. Fourthly, the altitude. The altitude is the height above sea level at which the circuit breaker is installed. The circuit breaker's amperage rating may need to be adjusted based on the altitude. Fifthly, the enclosure. The enclosure is the box or cabinet that houses the circuit breaker. The enclosure should be appropriate for the environment in which it is installed. For example, an enclosure that is installed outdoors should be weatherproof. There are also different types of circuit breakers available for different applications. Standard circuit breakers are the most common type of circuit breaker and are used for general-purpose circuits. Ground fault circuit interrupters or GFCIs are used to protect against ground faults, which can occur when electricity flows through an unintended path to ground. Arc fault circuit interrupters or RFCIs are used to protect against arc faults, which can occur when electricity jumps between two conductors, creating a spark. Dual-function circuit breakers combine the functions of both GFCIs and RFCIs. High-inrush circuit breakers are designed to handle the high inrush currents that occur when certain types of equipment, such as motors and transformers, are started. Multi-K circuit breakers are larger and more robust than standard circuit breakers and are used for higher amperage circuits. Solid-state circuit breakers use electronic components to detect overcurrent conditions and trip the circuit. They offer more precise and reliable protection than traditional electromechanical circuit breakers. Smart circuit breakers can be monitored and controlled remotely. They can provide information about circuit conditions such as voltage, current, and power consumption. They can also be used to remotely turn circuits on and off. The selection of the appropriate type of circuit breaker depends on the specific application and the types of overcurrent conditions that are likely to occur. Consult with a qualified electrician to determine the best type of circuit breaker for your needs.